right, the last problem we spent all on number 13. All right, and we got to our final answer in the graphing calculator that looked like this. A whole lot going on. But by hand, we were able to figure out that this right here, this was our solution to our graph. And so what we're doing now for problem number 14 is we're listing 3 possible solutions, like how many adult tickets and how many student tickets would you have to have in order to get bigger than 3,630. So we're going to throw in some numbers and see if they work. Jacob, were you able to find a solution?
Yeah.
Not the only one, but just one that works. How many adults did you find?
The first one was 250.
250. So he has 250 here. What's the maximum you could put there? 50. So we did 250 and 50. When you did that in the calculator, what did you come up with?
4,300.
4,300. So this and this, that's a revenue of 4,300. Did anybody do less than 250 for adults? What you got, Zach?
115 and 185.
115 and 185. So now together, those still add up to 300, all right? But they're not over 300, so you got a packed house. So we have a packed house here, and we have a packed house here, but we're going to make different money. What'd you get?
3,760.
Right. So what does that tell you as a business owner? I mean, it's not just for school raising for school money, but like if you're owning a business, you're like, hey, I want more adults than students. Well, no, we got to bring in the kids. Otherwise, you're only going to get, never mind. Well, move on. All right. What if we did like not a whole lot of adults, and we did like a whole lot of kids? Did we still meet the criteria? Try that one. Do 15. And this is how you do it in the calculator. We'll do this one together. All right. So we'll say 15 times 100 plus 11 times 200 equals 3,700. Well, that makes sense. That's 1,500. That makes sense. That's 2,200.
Yeah.
Add them together, you get.
That's what I was trying to do.
Yeah, you can do that. Just do that in your head. All right, so we're at 3,700. And guess what? That's still that barely meets the amount, right? But it still meets the amount. So now that you know that, here's your 3 answers you could use. You could say the ordered pairs of 250 and the ordered pair of 115 and 185. You could use the ordered pair of 100 and 200. Those are 3 what? 3 different combinations of tickets sold that satisfy the inequalities. So a lot of times you just have to, there's not just one right answer, there's multiple right answers. How do you prove to your teacher that you know what you're doing? Where's the evidence of this? Right there, there's your evidence. So don't just put the answers, always give your teacher evidence of your logic, your reasoning. They really do appreciate that. Right? Now, that's problem 14, which is an extension of problem number 13, which we did. Now we're going to move on to the last 2 problems, which look very eerily similar to the one we just did. Now, my suggestion right here is I would like you guys to call the x-axis adults once again, and the y-axis are your children. All right? So there's the x-axis, there's the y-axis. I want you to try this on your own, but my suggestion is to scale every single number up by 20. So we go up by 20s here. All right? Go up by 20s here. So read through the problem. Come up with some inequalities. So write a system of linear inequalities. By the way, there's also going to be 4 of these guys. All right? So come up with that. Then we'll check your answers to see how you did. All right, here we go. Number 15, we're going to write 4 inequalities. All right? Now, if we wanted to figure out one of the inequalities, just talk about how many there are allowed to be in the theater. What's the maximum seating for the theater? 100. So what was the inequality, Jacob, that you made for the seating?
X plus y less than or equal to.
There you go. So that's the seating. That's the inequality for the seating. The number of the adults plus the number of children in the theater have to be less than or equal to 100. So that deals with C. Then we have the money one. So Zach, what's the money one dealing with the amount of money you're trying to make?
10 times the number.
So 10 times X, that's the adults. Good.
Plus 5 times Y.
5Y. Now here's where it gets tricky. We have to do not at least, but
Greater than.
yeah. So greater, so it's not at least greater than, so this got to be greater than 600, which is going to change one of our lines from being solid to dotted. So this one's going to be you're going to see a dotted line. This one you'll see a solid line because there's an equal to, okay? Now, there's 2 more inequalities. How many adults have to go to the theater? 0, right? But they could be greater than that. So we're going to say X could be greater than or equal to 0, but we're not going to shade it because it just looks ridiculous. So we're not going to shade these, but we know that this whole area right here technically would be shaded if we wanted to. All right? Now, let's take X plus Y is less than or equal to 100, and let's look at what the X and the Y intercepts are. We put X intercept and Y intercept. Now my X intercept, my Y value is 0. My Y intercept, my X value is 0. And we look at it right here, we just cover them up. If I want to solve for X, what's it going to be? 100. Solve for Y? 100. That was easy. Now this is the solid line. So right here at 100, I want you to put a point. Right here at 100, put a point. And just connect your line. Just like that. Now where would I shade this? I'm allowed to shade underneath it because you have a positive Y, and that sign won't flip if we were solving for Y. So we're going to shade everything below it if we wanted to. Okay? Now, let's look at the next one. We have, this one's a little bit trickier. We have 10X plus 5Y is less than or equal to, oh no, my bad. Greater than, my bad. Greater than 600. So I'm going to change colors here. All right? I'm going to change colors. And this is where, when you're looking for your x-intercept, that's where you can take your c value and divide it by your a value. And your y-intercept right here, you're going to take what? Your c value and divide it by your b value. So let's think about this. We have ax plus by is greater than c. Our c value, our a value, and our b value are very easy to locate. So if you're still confused about where is he getting a, b, and c, this is called, what form is this called again? Standard. So my a value is 10, my b value is 5, my c value is 600. So what is c over a? What is 600 divided by 10? 60. So 60, 0. And over here we have, what, 600 divided by 5, and that gives us 120. So there's your x-intercept, there's your y-intercept, bottom. 60, 0, 0, 120. 60, 0, 0, 120. Now you probably see why we counted by 20s. All right? What kind of line, though? Dotted. Make a nice dotted line. There we go. Which means this. Which means anything on this line is not going to be a solution. Okay? The blue line, we're going to shade everything below it. The purple line, we're going to shade everything above it. And once again, you see where the money is being made. The money is being made in this region right here. This is the money-making region. Do you think businesses need to know where the money-making region is?
Probably.
Yeah. So once again, let's review this. If I said this is the amount of adults and children, whatever that point is right there, that ain't going to work. I know you can't have half of the kids and stuff like that, but just saying. Any point on that line does not work. However, any number that is perfectly on this blue line or slightly below it, right? Okay? or just over here, any point in this region will work. Or anyone on that blue line except for that where it crosses over. Okay? So not over here, but just over here. Alright, so let's see. We're done with that part. Can the theater make a profit if no adults come to the performance?
No, they can't. On that five minutes.
Let's see, we have 10x plus 5y equals a certain amount of money. So if no adults come, none of them come. What's the maximum number of kids that could come? 100. So if it was filled up with a bunch of kids, you're still only going to make 500. And that's not going to work because we want that to be equal to more than. We want it to be what? Not equal to, but greater than 600. That was horrible. You do a better job of raising. We want this to be greater than 600. So your answer would be no. It's in this time, they could make 500 max. And there's your evidence. So it's not just no, you're providing evidence, no, they could make 500 if there was no adults. And that's the final problem. This is going to be due tomorrow. If you haven't finished the assignment, you can do it tonight. I won't let you.